Hello and welcome back. Today we're going to be talking again about our proportional relationships, and we're looking at lesson 6, page 7. So please make sure you're on that lesson. You're going to notice that once again we're talking about proportionality in tables, and this is such an important concept that we're going to spend one more lesson on this. My plan for today is to do the first table with you, then I'm going to ask you to pause and do the second table on your own, and then we'll answer some of the questions together. We'll also start the third table together. We'll pause, have you finish that, and then again we'll answer the questions together. So that's the plan for today. So let's start by reading the opening statement. Relationships are blank if they can be represented by the equation blank, where K represents the constant of proportionality. So relationships are proportional. That's what we've been talking about, proportional. Should be an A and an L. If they are represented by the equation y equals kx. And again, you can write this equation kx equals y. We've just reversed sides, but you're going to notice that the k stays with the x, the constant of proportionality. And that brings us to this point. We want to make sure that we know that the k value is the same thing as the constant of proportionality. So now let's read what the situation is that we are given is. There are two coffee shops in town that charge different prices. The prices are proportional, but some of the information is missing from their price list. So we're going to work on together Seattle Coffee Works table, and then I'm going to ask you to work on Houndstooth Coffee on your own, and you can use Seattle Coffee's table as a model. So let's see the information that they gave us in the table. They're mentioning cups of coffee, and we're going to consider this the X column. And it just goes 1, 2, 3, 4, 5, 6 right in a row. That's called consecutive numbers. And then the Y column would be total cost. And they've given us two X and Y values to work with. So that's very helpful since we want to try to find out what the constant of proportionality is. In other words, how much does it cost for 1 cup of coffee? So I'm going to start with $3 and $8.25. And according to what they give us here, the Y value, which is $8.25, has to be divided by the X value, which is 3. And I've already done it in the calculator, so this is $2.75. So in this case, because the constant of proportionality represents money, I'm going to go ahead and write it that way. So what would you expect to happen when we took $13.75 divided by 5, the Y divided by the X? If you thought it was going to be $2.75, you are correct. So we now know that the constant of proportionality, the K value, is $2.75. We also know that that's the amount for 1 cup of coffee. So we're going to go ahead and write this in here. So they would like us now to fill in this table. And it's fair to say that since we know that the constant of proportionality is $2.75, it's fair to say that this would always be $2.75. They're going to ask us now to fill in the Y values, and we have two tools we can work with. And the first one I'm going to talk about really only works if we have what's called consecutive numbers. We have 1, 2, 3, 4, 5, 6. So those are going right in order up 1, which means we could then, if it's $2.75 for 1 cup of coffee, we could add another $2.75 to get the next price, which would be $5.50. And if we did that correctly, if we added another $2.75, we should get $8.25, and so on and so forth. So that's one of the ways we could do this, and that really is only going to happen or be possible as long as we have these numbers in consecutive order. The other way to do this, now that we have an equation or have learned about an equation, y equals kx, or in this case I'm going to use kx equals y because y is what we don't know, we know that the k value is a constant of proportionality. So we could take $2.75 times the x value of 4, and that would give us how much it is, the total cost for 4 cups of coffee. That would give us our y value. So when we take $2.75 times 4, we get $11. And if you would like to double check that, if I added $2.75 to $8.25, it would be 11. So the next blank y, we would use our equation. Our k value is $2.75. Our x value this time is 6 cups of coffee, and that's going to give us our y value, kx equals y. So in this case, when we multiply 275 times 6, we would get $16.50. So I'd like you to pause the video and complete the next table for Houndstooth Coffee using what we did to complete this table. Let's recall what we did last time. We took our y values, total cost, and first example it's $5.60 divided by 2, and we had another example, $16.80 divided by 6 cups of coffee. Both examples led to 2.8, which in this case is $2.80. We then said that for 1 cup of coffee, since this is a constant of proportionality, it's also the unit rate, and unit rate means the price or the rate for 1. So we know that for 1 cup of coffee, it's $2.80. This meant that all of the k values, or the constant of proportionality, was $2.80. It also then led us to being able to fill out the rest of that. Now, once we know the k value, right here the k value is $2.80, I can use that in my equation. So instead of using y equals kx, I just flipped it around, and I put my k values all in front, multiplying my x values, these are all x values, and that led to my y values, the ones that I needed to know. Now again, because these are consecutive numbers, 1, 2, 3, 4, 5, 6, and consecutive means in a row, right, in order, I was able to use also, I could have used a pattern by adding $2.80 each time we went down the column, because we're basically adding 1 more cup of coffee, and each cup of coffee costs $2.80. We would not be able to use this addition method if this was going up by 3s or not in a pattern. So now let's look at the questions that they ask us. A reads, what do you notice that is different about the 2 tables? So they're asking us what's different. So the constant of proportionality is different in each table. That also happens to be the price for a cup of coffee. The next question asks, all right, what proves that both coffee shops sell their drinks at a proportional rate? Again, that word proportional is important. So once again, if we look at this, what proves that they are proportional is they have a constant of proportionality, constant rate that they're changing by. So in other words, the ratio in each table of x divided by, y divided by x is constant. Question C says, if you purchase 9 cups of coffee at Houndstooth Coffee, how much more would you spend than if you purchased 9 cups of coffee at Seattle Coffee Works? So the first thing I want to do is I want to highlight important information. They mention 9 cups of coffee, and in both tables that is the X value. So I'm now talking about the number of cups of coffee. They also ask how much more would you spend. So we're looking for the amount of money, which is the Y value. So we don't know the Y, but we do know the X. Unfortunately, they didn't give us very much room to work on this problem underneath the letter C, so I'm going to move it down here, which I hope you can. I'm going to talk about Seattle's coffee first, and their equation, y equals kx, would be represented by y equals 2.75, $2.75 for each cup of coffee, x. And if you prefer, we can write it this way, and that's how we used it in the table. $2.75 times x equals y. And that's probably more efficient because that's the way the table is written. So I'm going to take $2.75, and they mentioned 9 cups of coffee. So I know the number of cups of coffee they're looking for is 9. So we're going to pause and calculate $2.75 times 9. And hopefully you came up with $24.75 for 9 cups of coffee. Now we're going to go after Houndstooth Coffee. We want to know how much we're going to pay for 9 cups of coffee at Houndstooth. Again, their equation would be y equals $2.80, y equals $2.80 times x. But because the table kind of gives us the information as x then y, we could also write it as $2.80 times every cup of coffee would give me back my cost, which is y. So we're going to say $2.80. Once again, we're given 9 cups of coffee. And if we calculate that, it would give us $25.20. So $25.20. But we're not quite finished because the question asks, how much more would you spend at Houndstooth in Seattle? So in order to find that, we have to find the difference. We're going to take $25.20 minus $24.75, and that would give us 45 cents. So the answer to the question is we would spend 45 cents more for 9 cups of coffee at Houndstooth. And this, I probably could have had enough room to write it in this space right there. All right, so now at this point, I'm going to ask you to complete the table for Stumptown Coffee. Let's read the situation and see what the questions are. Let's kind of preview what they're asking us. It says a third coffee shop is opening up in a busy business district. What do you notice about their pricing structure? Well, we don't know yet because we haven't figured out what the constant of proportionality is or if there is one. And then it asks what would be the benefit to this structure. So it's kind of implying there might be something different. I'm going to ask you to pause the video, use your calculator. You're going to take all of the y values divided by the x values. And I don't want you to stop after the first one. I want you to do each one of them individually because you might be surprised by the answer. Okay, let's briefly share out. Hopefully you noticed that each time you did y over x or y divided by x, the price went down by 5 cents for each cup of coffee. And so what we noticed, hopefully, is the cost decreases as you purchase more coffee. And so that's what we needed to notice. And what would be the benefit? Well, it's less expensive if you buy more. And this is a classic marketing, I'm going to call it a ploy. Marketers do this because that encourage us as consumers to buy more because we're getting a bargain, we're paying less. Finally, I just want you to notice that because this is not constant, this is not a proportional table. Thank you for your time, and we'll see you next lesson.